Hi, this is Devar studying in Institute of Aeronautical Engineering. I am studying BTech first year Computer Science Engineering. Today we are going to discuss about the mathematical functions in Python. Python is a high-level computer language which is easily understandable by the user. Python Math is a built-in standard module that is used to work with complex scientific calculations. A mathematical function is a rule that gives value of dependent variable that corresponds to the specified values of one or more independent variables. A function can be represented in several ways such as a table, formula, or a graph. In a Python, a number of mathematical operations can be performed with ease by converting or importing a module named math, which defines various functions which makes our task easier. There are some calculations based on maths in Python. Some calculations are easy and some calculations are complex. Complex the complex calculations will be converted into easy calculations by using some mathematical functions. To use a mathematical function To use some mathematical functions, we need to import it to a math module. If we did not convert or import a math module, we cannot use some of the mathematical function, and we need to type a bigger code. The outcome of the topic. Every student, after observing this video or PowerPoint presentation, should be able to do or solve and execute all the mathematical functions in the Python. Mathematical functions in Python are divided into four categories, or there are four types of functions: numerical functions, power and logarithmic functions, angular and trigonometric functions, special functions, and constants. Numerical function. There are six numerical functions. There are six power and logarithmic functions. There are six trigonometric and angular function, and there are three special function and constants. Numerical function are definitely based on numbers. They are simple and easy to execute. The first function is seek. This function returns the smallest integral value greater than the number. If number is already integer, same number is written. This function prints the output, the number that is nearest integer to the number we have taken, which is greater than the integer that we have taken. We need to for writing a code, first we need to import to the math. Next, we need to take the input from the user, or you can also give. Next, print math dot seal of x. X is the input that we have given, and math dot seal, it's the syntax of the seal function. We have taken the input as 23.6. 23.6 will be converted into the nearest integer which is greater than the number we have taken. We have taken 23. Do not worry about the decimal point. We have taken the 23. The output should be 24. 23.6. 23.1234567, any decimal point and any numbers which will be converted into the 24. The next function is float. This function is just opposite to the seal function. This function returns the greatest integral value smaller than the number. If number is already integer, same number is written. This function prints the output that the nearest integer less than the number that we have taken. Its reverse. Seal function will print the greater number that we have taken. This function prints the less than the integer we have taken. First, we need to import to the math module. Next, we need to take the input math.floor of x. X is input. Math.float is the syntax of the function. Okay. We will take. I have taken same example. You can take any of the number. 23.6 will come. The output will be the 23. 23.129 decimals point. Do not bother about decimal points. Next function is fabs. This function returns the absolute value of the number. Absolute value, it will convert negative to the positive integer. Positive number, not the integer. First, we need to import to the math module. Next, we need to take the input. Math.fabs is the syntax of the function. We need to print the math.fabs value of minus 10. Minus 10, the positive value of minus 10 is 10. Okay, this function print the absolute value. Absolute value means modulus of the function. Minus 10. will be converted into 10.0. First, all these functions will print the value in the float until and unless if we give any unless if we give integer type or any of the type. If we need integer value as input, we need to add int function in the print statement. Next function is factorial function. This function returns the factorial of the number. An error message is displayed if the number is not integer. Exactly. The integer number can be taken as the factorial. Otherwise, it will give an error. First, we need to import the math. Next, we have to take the input, print statement. Math.factorial is the syntax of this function. Every function before we need to use the math. Already we imported to the math module, but also we need to use again. Okay, 5. We have taken 5. 5 factorial 120. It also prints the number in the float. This function returns the number with the value. Okay, copy sign. Copy sign. This function returns the value with the number of a, with the value of a, but with the sign of p. The return value type is float. Every function will print the value is in the float code. First, we need to import the math. We need to take two inputs. One is in negative and one is in the positive or negative. No problem. Print statement math.copy sign of a comma b is the syntax of the function. Okay, it will copy the sign. This function copies the sign of a and it will give it to the b. Simple. We have taken a as minus 10 and b as 5.5. It will the sign of a is negative, b is positive. The sign of a will be copied to the b. It means b will become negative. If we take a as positive, b will become as positive. GCD, greatest common divisor. This function is used to compute the greatest common divisor of two numbers mentioned in its arguments. Okay, import math. We need to import the math. Next, we need to take the inputs. Print math.gcd is the syntax of the function. A comma b 5 comma 15. There is no need to take the input. Just we can give in the print statements 5 comma 15. The GCD of 5 comma 15 is 5. You can give any of the numbers. It will print the value in the float. Next, here we came to the end of numeric functions. Next, logarithmic and power functions. There are 6 logarithmic and power functions. This function return the values of e exponent of a. This function returns the value of e raised to the power of a. It means e power a. A is the input we will give. Okay. First, we need to import it to the math. Next, we need to take an input. Next, print statement math.exp. Every function before math, it's the syntax of the math module. Math.exp of b. Okay, b is the 4 we have taken as the input. B exponential. Okay, it will print the value of e power 4. In place of b, you can give number 4 in the print statement also. Output is 54.598115003311444236. It's the value of e power 4. Next is log of a comma b. This function returns the logarithmic value of a with the base b. If base is not determined, the computed value of natural log. Here the function prints the value of log a to the base b. If b, that means base, this is not base. If base is not defined, it will take natural. It will compute the value of natural log. It means it will compute the value of to the base 10. First, we need to import to the math module. Next, we need to take two inputs. Inputs are not necessary. We can directly print the value. Next, print the value of log 2 with the base 3 is end. Okay, I will explain now. In the print statement, the text written in the double quotes will print as it is. Next, end is the function to print in the same line. Print math.log a comma b. Math.log a comma b is the syntax. See, we have taken a 2 and b3. The output will be the value of log 2 with the base 3 is 0.630929529753571457. Next, log 2 to the base a. This function computes the value of log a with the base 2. This value is more accurate than the value of function discussed in the last slide. Last slide we discussed log a to the b. There b the base should give the base as input, otherwise it will take the base 10. Import first we need to the import max a equal to input, no need to give. Print mat dot log 2 to the base 2 a to the base 2 a. Output will be the 4 because 16 we gave as an input. Log 16 to the base 2 is definitely 4. This output also will be given in the form of float. Log 10 to the base log 10a. This function computes the value of log a with the base 10. This is more accurate than the value function discussed in the last slide. In the last slide we have discussed with the base 2. With the base 10 value is more accurate than both of log a to the base p and with the base 2. First we need to import module to the math. Next we need to give the input. No need necessary, not necessary that much. We can give any of the input. Print math. Next print statement. Print math dot log 10 a. We have declared as 10. Log 10 to the base 10 is a 1. This function will print the value in the float type. Next, power of a comma b. This function is used to compute the value of a raised to the power of b. Power of a comma b. First a, next b. We have declared a power b will be as the output. First, we need to import math module. Next, a, b. Two functions to variables we need to give as input. No need to give. Print math dot power pow a comma ba. This is the syntax. This function also prints the value in the float type. All the functions will print the value in the float type until we use int statement, int like functions in the print statement. Next function is square root. This function returns the square root of a number. Square root, everybody know about the square root. Import math first. Next, a equal 25. Now we need to give the input. Print math dot square root of a. If we did not give the input, in the place of a we need to write the number. Root of 25, square root of 25 is 5. This function also print the value in the float. Okay, here we came into the power and logarithmic functions. Next is trigonometric and angular functions. There are 6 functions. First function is sine. This function returns the sine value passed as argument. The value passed in this function should be in radians. This is the condition. Import math. First we need to import math. Next, a equal to math dot pi by 6. See, if we did not import to the math module, a equal to math dot pi by 6 will be invalid. It will be stored as an it will give error if we use this function without importing to the math module. Okay. Next, math dot sine of a is the syntax. A is pi by 6. Math dot pi is only defined in the math module. Okay, pi by 6, sine pi by 6. It means pi by 6 means 180 by 630. Sine 30 degrees value is half. Output is 0.4999999 and some 9s and 4. It is nearest value to 0.5. You can round to the value up to how many digits you want using the round function in the print statement. Next function is cos. This function returns the cosine of value passed as argument. This value passed in this function should be in radians. Okay. First we need to import math. Same. Next, a equal to math dot pi by 6. A is a variable. We are giving it the pi by 6 value in radians. It should be in radians so that pi should be in radians, so that we need to import to the math module. Next, print statement. In print statement, math.cos is the syntax of this function. A as pi by 6, pi by 6 30 degrees, same cos 30 is root 3 by 2, value 0.8660254037844387 is the output. Tan of a. This function returns the tangent of value passed as argument. The value passed in function should be radians. This function gives the tan of the variable that we have declared. First, we need to input max. Next, same as explained in the sine and cos functions, a equal to mat dot pi by 6. Next, print statement mat dot tan a is the syntax. A or tan empty brackets pi by 6 tan 30 is 1 by root 3. It will be in float type value only, not in fractional. 0.5773502691896257. Hypot Next function is hypot a comma b. This returns the hypotenuse of the values passed in the arguments. Numerically, it returns the value of a into a plus b into b. It square root. It prints the value of root over a square plus b square, same as hypotenuse used in the right angle triangle. For this function also we need to import to the math module. Next, we need to declare two functions. We need to declare two variables. No need to declare. We can give in print statement also directly. Math.hypot is the syntax of this function. Print statement will be written as print math.hypot a comma b. In place of a comma b, we can directly give as 3 comma 4. A comma b. 3 and 4, root over 3 square plus 4 square, or root over 4 square plus 3 square is definitely root 25 and 5. This function also prints the output in the float type. Next, decrease. This function is used to convert argument value from radians to degrees. See this. If you in the last slides we have discussed three functions: sine, cos, and tan. In that we need to give radians. If we are giving it to the if you want to give it to degrees, we can use the function radians to degrees and give that value. Import math a equal to math dot pi by 6. Same. Print math dot degrees a. Math dot degrees is the syntax of the function. A is the value that pi by 6. Next, output will be as pi by 6 is 30 degrees. It is nearly equal to 29.999 some 9s and 6. It is nearly equal to 30. Here, every function till now we discussed except two, floor and seal, all they are integer type function, and all functions that we are discussed till now will print the value in float type unless until we have used some int like functions in the print statement. Next, radians function. This function is used to convert argument value from degrees to the radians, the reverse of the 3.5. It means degrees function reverse is this function. But code input math same a equal to 30 degrees. Print math.radian of a. Math.radian is the syntax of this function. Okay, 30 degrees. 30 degrees, if we convert into the radians, the value is 0.52359875758298298 radians. Okay, we are coming we here come to the end we here come to the end of angular and trigonometric functions. Next, special functions and constants. These special functions and constants, these are three functions: gamma, pi, and e. First, we'll discuss about gamma. This function is used to return the gamma function of the argument. First, we need to input the math. Next, we need to declare the variable or else leave it. Print math.gamma. Math.gamma is syntax of the function. If we did not declare the variable as input, we need to give in the place of a gamma 4 or something. Gamma value of 4 is 6, so this function also change the value in the float type. Next, pi. This is an inbuilt constant in the Python that outputs the value of pi. Pi value is 3.14592 and so on. Okay, first we need to import math. Next, print math.py. Without importing math, if you use this function, it will show an error because pi is a function defined in the math module of the Python. Math.py, it will show the pi value the pi value is 3.141592653589793. Okay. Next, e. This is an inbuilt constant that outputs the value of e. Same, it is also pi. Same like pi, it is e. E is used logarithmic. E is logarithmic. This is an inbuilt constant that outputs the value of e 2.718281. Okay, this half value. First we need to import to the import math. Next print math.e. Next output. Without using without importing module to the math, we can run this function, but it shows error. The value of e is 2.71828182845945. All these functions that we have discussed till now, except ceil function and floor function, will print, except those two functions, all the functions will print the value in the type of float unless until we use functions like int in the print statement. Thank you for listening with the patience.